Hello and welcome to this session, Transform with Microsoft on AWS. I'm Steve Bryan and I'm a member of our developer relations team here in EMEA, based out of the UK. In this session, we'll be talking to you about how you can transform your Microsoft workloads, move them to AWS, get advantage of the benefit of the performance, scalability, availability, and also some of the managed features that we have available in the AWS platform to enable you to accelerate your Microsoft workloads in the cloud. So let's dive into it. So the first thing you may be asking yourself is, why AWS for your Microsoft workloads? Well, one of the main reasons you would look to AWS is our experience. I think that's one of the first things to call out here, is that we've been doing this for over 12 years. We've been running Microsoft workloads since 2008. And we also have a huge amount of reliability, price performance, and a tons of capability and security enhancements on the platform compared to other providers out there in the market. So we'll take a look at the history of AWS and running Microsoft workloads. Well, as I mentioned, running for over 12 years, and we actually have built up a portfolio of over 14,000 partners now that are running workloads in Microsoft workloads in the AWS Cloud. And over those last 12 years, we've added a ton of capabilities to our platform as well. So if we look across the different types of Microsoft workloads available, you can see the addition of services over that graph that have been added to the platform. We can pick on a few here, some of maybe our more recent ones, like our AWS License Manager service or our FSX for Windows file server, which we'll touch on briefly in this session as well today, but also a ton of support for running general Windows Server on AWS as well. Obviously, SQL Server is a huge and popular workload for many of our customers running Windows. So we've had SQL Server support since the very beginning, running on EC2, and you see around the kind of 2012-13 timeframe, adding support for SQL Server for our RDS as well, our relational database service, a managed service for SQL Server that's been running now for 7 or so or more years in the AWS Cloud as well. And you can see support for the latest versions of SQL Server at the top of the chart there, such as SQL Server 2019 running on EC2 as well. So a ton of capabilities available for people running SQL Server. If you're a .NET developer, lots of capabilities available here for you, whether that's adding .NET support into services like AWS X-Ray, which is our observability and tracing service for microservices and distributed applications, through to launching AWS tools for PowerShell, so you can manage and support your AWS environment using PowerShell, or adding .NET support to AWS Lambda, which is our serverless computing platform. So .NET and Windows really being a first-class citizen on AWS. And finally, for those looking to do application modernization, support for Amazon EKS for Windows, running Windows on our Kubernetes service, which we'll touch on briefly later in the session as well, or .NET Core support on our Linux Amazon machine images as well. .NET Core obviously being a key capability that a lot of customers are taking advantage of today. So tons and tons of experience over the last 12 years of running Microsoft workloads in AWS, and a significant amount of features and capabilities available to customers across Windows, .NET, SQL Server, and application modernization capabilities and integrations as well. So when we look at reliability and the AWS capability, now I'm not going to spend a lot of time talking about our global infrastructure, but we have regions all around the world that have capability to support the workloads that you need to run. So wherever you are in the EMEA region or beyond, if you're watching this session, then there are regions in 26 different geographies around the world. A couple of them are in the works, on their way, the ones in orange that you see on the screen here. But we have 24 active regions around the world supporting to support your workloads in AWS. And when we talk about a region in AWS, we don't just talk about a single data center or a single facility. A region for us is a much more significant investment. In fact, a region comprises of multiple what we call availability zones, which are groups of data centers in a kind of a geographic area. So take London or Dublin or Frankfurt, for example. So a region is a huge investment for us in infrastructure, and because of this availability zone concept, we have a high level of availability for applications that our customers run in the AWS Cloud. And you can see the stat on the slide here shows that we actually have 7 times, as in 2018, we have the next largest cloud provider had almost 7 times more downtime hours than AWS. So that experience of running an operational excellence of running infrastructure at scale at Amazon really plays true there in our experience and capability to run these highly available services in the cloud. So let's look at the performance characteristics and dive a little bit into SQL Server. You can see both from a performance perspective on the right-hand side of the screen here, and for a cost perspective on the left-hand side of the screen here. When we compare the data available, this was an independent study done by a company called DBBest. They're an enterprise database consulting company. And they found that the cost was much lower for AWS, as you can see on the graph on the left, but the performance was much higher on AWS with the equivalent configuration on the other provider there as well. So AWS consistently outperforms other providers across a variety of different machine types and sizes in running SQL Server in the cloud. So in some cases, 2 times plus better performance. And actually, the benefit there, it comes from the power of the infrastructure available for running workloads in AWS. And obviously, our partnership with Intel is very important here in running these workloads. You can see just an example here of an addition to the instance family. We added our M5 instance family. This is our general purpose instance family, which was the upgrade from our M4 instance family. You can see that by adding this Intel Xeon processor, which is ideal for in-memory OLTP databases, we're able to see 72% performance improvement in running SQL Server on AWS on those new instances. In addition, that Xeon processor brings a ton of additional security capabilities that are embedded into the Intel processor as well. So tons of performance, and a lot of that powered by our partnership with Intel and the capabilities they're able to provide to optimize for in-memory OLTP and other offerings and capabilities and features that are available from SQL Server. Another thing that's unique about AWS is that we run our whole infrastructure on something called our Nitro platform, or our Nitro system. Now, it starts with the Nitro hypervisor that you see on the right here. This is a lightweight hypervisor that allows us to run our virtual machines at scale, our EC2 instances, as we call them, in the AWS Cloud. But the real benefit of Nitro is this: the chips, the Nitro cards, and the security chips that we have custom developed here at AWS. These are custom silicon that's developed purely for running these operations. So, for example, whether that's encryption, for example, from a security perspective, or storage operations using the Nitro card, we actually are able to offload all of those operations onto these custom silicon, which gives you the maximum performance when you're running your virtual machine. So you get near bare metal performance when you're running your virtual machines on EC2 in the AWS Cloud. So we don't have a ton of time to go into the Nitro system. But it's a fascinating piece of engineering, and there's a lot of information out there in the open about Nitro, and I encourage you to look at that if you're interested in how we do some of that offloading of storage and security operations to custom silicon. It's a really, really fascinating space. So if you're into that kind of stuff, I encourage you to take a look. We also have the capability to run bare metal instances. You see the example here of the i3 metal instance type and some of the capability that it has available there. It has the Xeon, the Broadwell processor, 512 gigabytes of RAM. This is a bare metal instance, so you are getting access to the raw bare metal to run your workloads. This is obviously a large instance type, but it's designed for workloads that are not virtualized or require specific types of hypervisor or have licensing models that restrict you from virtualizing your workloads as well. And this is actually, if you've seen the VMware Cloud on AWS, this is actually the technology that powers that. So VMware leverage this capability to build their VMware Cloud on AWS platform. So we spoke a bit about AWS and some of the core capabilities, EC2 to run Windows workloads, a little bit about our infrastructure and reliability experience, and then also a bit on SQL Server performance and running SQL Server on AWS. But what are the innovations we're doing at AWS? What are we doing that's beyond all that cool performance stuff? And Nitro is obviously a huge innovation here. What are we doing from a Microsoft-specific perspective to bring more capabilities to our customers? Well, the first thing I want to talk about is Amazon FSx for Windows File Server. This allows you to run a managed Windows file server in AWS, and you don't have to worry about managing it or managing the servers or scaling it. You're able to lift and shift your existing Windows file servers systems or Windows file systems to this environment, and it you turn up the throughput, and you turn up and you add storage to it, and you pay for the amount of storage that you use and the throughput that you provision to that storage, and you're able to access it over the SMB protocol. So a cloud native way for running Windows file server in AWS, and for your applications and servers to connect to that using the SMB protocol. So fully native Windows capability built on top of Windows Server as well, and obviously high performance with SSD-backed storage as well. So this is a real innovation and new capability that allows you to have a managed Windows file system for your applications in AWS that's consistent and compatible with your existing workloads that you're running today. Now, another application or service that we launched last year is something called AWS License Manager. This is a one-stop shop and solution for managing licenses from a variety of software vendors across different hybrid environments. Now, this allows you to stay compliant according to your organizational structure or process that you put in place, but also allows you to have integrated management with things like bare metal or EC2 dedicated hosts as well, where you may be bringing your own license and not using the AWS included license. So it supports automatic discovery of existing licenses in AWS, and gives you better visibility and tracking of your licenses and how you're managing them. So when you think about options for bringing Microsoft licenses in the AWS cloud, there's a few options available to you. The first one is on the left-hand side of the slide here is, by license included instances from AWS. This includes Windows Server and SQL Server in your hourly or cost that you pay us, or per second cost, however you pay for your EC2 instances. That license is included in the cost that you pay to AWS, so you don't need to worry about buying an operating system license, for example, if you run a Windows AMI or Amazon Machine image in the EC2 platform. But you also have the capability to bring your own licenses to AWS if you're using dedicated options such as bare metal instances or EC2 dedicated hosts. And then you can also bring other licenses to AWS for your Microsoft applications that have license mobility associated with those license contracts that you have in place with Microsoft. So you're able to bring those application licenses over and run them on top of your Windows Server workloads in AWS as well. There's various different options available for you. So you can let License Manager periodically track the software usage in your accounts and update the dashboards for you without having to do any manual effort. So you define it once, and then License Manager takes care of the rest for you. And you can see that you're also able to report on the usage. So you can see usage of bring your own licenses that you've imported into the manager. But also you have this new filter here where you can filter on licenses that are included. So license included with AWS services and products that you're procuring through AWS. So you can start to break down your dashboards and visualize your licenses and where they're allocated. Now, another challenge for a lot of customers is that Windows Server regularly, not regularly, but obviously in the cadence in which it's supported, will become end of support, and that's a big challenge for customers. In fact, that by most estimates that we see from analysts, around 40% of all Windows Server installations are 2008 R2 or older. And Windows Server 2008 R2 and Windows Server 2008 both went end of support in January this year. So what does that mean for customers? Well, that means that there's no security updates. That means there's increased exposure to vulnerabilities in the ever-growing security landscape that we're operating in. You may not be compliant with industry regulations that you may need to abide to. Your operational costs will be high, and you're actually limited in your cloud adoption. If you're using legacy software and legacy operating systems, some of the capabilities to move forward and leverage things like containers and other workloads are restricted by your use of that version of operating system. So not taking advantage of upgrading your operating system actually can sometimes limit you from innovating and taking advantage of cloud native technologies looking forward. So there's a ton of migration challenges when we think about legacy applications. There's maybe lost expertise, lost codes, you don't have the installation media anymore. That's very popular. There's potentially a high cost and time commitment in refactoring those applications. There's a high risk that that upgrade is going to fail, and this failure is going to be part of that. Customized commercial off-the-shelf software may be costly to or incompatible with newer versions of software, and you need to pay hefty license fees to upgrade the versions of that software as well. And there may not be the right time for you to do that. You may actually be innovating and building a subsequent product, but you just need to run this legacy piece of software for a short period of time. And also you may have dependencies on other runtimes and legacy runtimes as well. So this is just a real challenge for customers. They want to migrate. The risks are significant if you don't, but there's a huge complexity and challenge in actually migrating these applications, and a huge effort potentially from a cost and a manpower involved in doing so. So AWS has a really cool solution for this, something called the End of Support Migration Program for Windows Server. Now I know that's a bit of a long product name, but let's just call it EMP as we move through the rest of the presentation. Now, what does EMP do? Well, EMP allows you to migrate legacy applications from a previous version of Windows Server to a supported version of Windows Server. So if you're running critical workloads on legacy unsupported platforms, and you have no clear path forward in terms of refactoring, or the cost to do so is so significant, then EMP is the solution for you. So let's look at how that works. Well, it's basically a technology that allows you to package your legacy applications to run in newer versions of Windows Server without having to refactor. This might sound like the kind of perfect solution, but in fact it's a pretty smart piece of software, and the way it works is really interesting. But it allows you to future-proof your applications, improve your security performance and compliance by moving to supported versions of your operating systems. And there's many customers already taking advantage of the EMP for Windows Server today. National Australia Bank are planning on utilising a partner called CloudHouse to accelerate their migration off of unsupported versions of Windows Server. They're looking at migrating servers in the thousands. Obviously, they're a huge enterprise customer of ours, and Origin and Inmarsat are other customers there as well that are using the platform as well. So the way this works is you have your legacy application, and you have this application is running on an older unsupported version of Windows Server, let's say 2003 or 2008, one of the iterations of 2008. And what the EMP compatibility package does is it actually assesses your legacy application in that environment. And it's got two supported options. The first option is if you have the installation media available. What this will do is it will basically snapshot and then record the delta of changes that are made when that application is installed. And it's able to understand the files and dependencies and registry entries that are created when that application is installed. But that's only part of the puzzle. The next part it does is then it allows you to run that application, and it also records what that application does when it's running as well. Are there any other dependencies? Can it intercept any of the Windows API calls to understand how that application is running and working, and package that into this compatibility package as well. And then if you have applications where you don't have the install media, you have an option to capture those as well in runtime and understand how they operate as well. So that's a really interesting piece of the software, where if you have those challenges, I encourage you to dive a bit deeper into that, because there's a really powerful feature that allows you to package applications without the installation media, which I think is just going to be really powerful for a lot of our customers out there. So this legacy application is now packaged. You're able to run it in this compatibility environment, this kind of isolation environment that runs on a newer version of Windows Server, 2012, 2016, 2019. And the compatibility package allows you to run that legacy application. It's understood, it knows what the dependencies are, it knows what registry entries are required. So quite often you'll try and install this software on Windows Server 2019, it will say incompatible. Well, now, because you've actually installed it in this compatibility environment, you've taken that package from your previous version, you can now run it successfully in a new environment, but still have access to those Windows system calls and other applications and dependencies that it may need access to. So a really powerful tool for our customers to get out of that kind of stress of running an unsupported version of Windows Server. So we've looked at how we can migrate legacy applications. We can manage our licenses. We can run EC2 and Windows on EC2 and SQL Server. We can manage our file systems using FSX for Windows File Server. So tons of capabilities and ways for us to migrate to the AWS Cloud. But optimization is obviously a really important part of running in any cloud environment. So when we look at optimization, first thing we always need to think about is cost optimization. And actually, cost optimization starts before migration. So cost optimization, first thing you need to identify, optimization opportunities for your resources that you're looking to migrate to AWS? Do you have underutilized? Do you have overutilized resources in your on-premises environment? Do you have outdated hardware that's requiring significant licensing costs? Maybe that's a good place to start looking at migrating, so you can reduce some of those license costs in AWS. And then on the Microsoft side as well, are there license savings you can make? Is moving to a bring your own license model a good idea? Can you use license included in AWS? Can you reduce your future enterprise agreement commitments by doing any of these things, depending on how you're operating at the moment in your environment? So one of the key things and challenges that we see from customers when they run on premises is that the infrastructure costs are typically high. There's a huge upfront investment typically in a capex investment investing in hardware, but in fact their server utilization is often much lower than their actual capacity. It's very hard on premises to build an optimized infrastructure where you are utilizing infrastructure at any rate that really makes economical sense. In fact, typically customers run at very low utilization from a hardware perspective. They buy more hardware than they need to make sure that they can reach their peaks for those short periods that they need them. But for the majority of the time, they're running at a much lower capacity, which incurs a huge amount of kind of wasted cost when they're doing so. And based on research from analysts, we can see that actually 84% of on-premises workloads are over-provisioned in terms of resource, and only 16% are accurately provisioned. This is a significant number, actually, and personally, I don't think I've found one of those 16% customers before. I think it's, in my experience running on-premises workloads, you almost always over-invest on your hardware just in case, and quite often contractually that's a kind of attractive thing to do as well. So huge challenge here for customers that they over-provision on premises, but there's a huge opportunity here to cost optimize when you move to the cloud and not over-provision and right-size your workloads. So one of the key things to do is do a migration assessment, and we have some partners available to help you here. TSO Logic, which is actually an AWS company now, CloudChomp and Cloudomize are ones that we specifically work with on Windows workloads, and they're able to give you an overview and an assessment of your existing environment and give you a comparable cost to what that might look like in the AWS Cloud. So when we look at over-provisioning infrastructure, one of the challenges is that many customers make this, let's call it a mistake, of when they move to the cloud, they say, I've got these 200 servers running on premises, I want to run them exactly the same in the cloud. And quite often that can lead to a more expensive price tag if you just do that like-for-like comparison. Specifically on storage, actually, I see a lot of customers that over-provision storage. They say, we've got all these virtual machines with 50 gig boot drives, and none of them are running at 50 gig capacity, and they don't actually store any application data or anything on those kind of operating system drives. So there's a ton of opportunity to optimize storage specifically, but also from a compute perspective as well. So what we saw in this study here, this was actually a study that we did using TSO Logic. We looked at over 100,000 servers running across various enterprises and various applications. And we found that when you move to, well, the on-premises cost was about $140,000. Moving to a kind of direct match in the cloud was about $170,000, give or take a few thousand. But when we actually optimized and used the TSO Logic tool to right-size our virtual machines or our EC2 instances that we migrated to in AWS, we saw that there was a cost saving of 36% on the annual on-premises cost. So by right-sizing their workload, they're able to reduce their capacity significantly. And this applies to Windows Server, this applies to your general kind of operating systems, but it applies to your applications as well. Here's another example of SQL Server workload running on AWS. Saving numbers a little bit lower here, but still significant, 22%, almost a quarter of your costs saved running your SQL Server workloads. On premises, this workload was $800,000. The direct match was $950,000, and then if you actually right-sized with SQL Bring Your Own License, was down to $650,000. And hopefully you can see it on the screen here. It's a bit small, but you can see that actually one of the optimizations here was that the on-premises environment was over-provisioned by about 100 vCPUs. So that's a significant amount of CPU power that was not being used on premises, so you're able to right-size in the AWS Cloud. And I think one of the other benefits that you should be aware of in AWS is that you can not only right-size now, but you can continually right-size. You're able to stop and start an instance or migrate an instance to a different instance type, whether there's a new one that's launched with better cost performance, or whether your application needs change and you need more performance for that instance. So the cost of change and the kind of window of change is much smaller. You don't have to make this upfront investment in years and years of infrastructure as you would with an on-premises environment as well. That's a general benefit of running your compute workloads in the cloud. We also have a program called MAP, which is our migration acceleration program. We launched this in Q1. You can see the link on the screen here. This is a program for that basically has a framework, and it provides enhanced incentives to offset the initial costs of your large-scale enterprise migrations to AWS. So you can apply for more information there on the website, but we work with partners to help you accelerate that migration of your Windows workloads to AWS, and there are some incentives available for large customers there as well. So the final section I want to look at is modernization. So when we talk to customers, running their workloads in the cloud is one thing, but they want to modernize. They want to move forward and have more cloud-native applications running. And there's four kind of dominant modernization pathways that we see when we speak to our customers. The first one is moving to serverless. Now, I don't have a ton of time to talk about serverless. There's a load of content available on serverless in the summit today, so I'd encourage you to explore that. But serverless is this new computing model where you only pay for the resources you use, you don't pay for idle, and you break down your compute to a very specific per function model where you only pay for the time that your code is executing. And we support .NET there in our Lambda and PowerShell in our AWS Lambda serverless compute product there as well. Second thing is containers, which we'll touch on shortly as well. SQL Server to Linux is obviously another big way to save some costs and optimize and be a bit more forward thinking. And another thing is some people are looking to move away from SQL Server to a more cloud-native managed OLTP enterprise-grade database. And Amazon Aurora is an Amazon-built and managed database that would allow you to do that. And we have schema conversion tools and database migration tools to support that. We have a session later today in the summit around database freedom. So I'd encourage you to look at that if that's something you're interested in. So first thing is SQL Server on Linux. This, again, huge cost savings here, 20% cost savings versus running on Windows. This is based on data from running Windows with SQL Server Standard and Linux with SQL Server Standard. You can see across both our M5 general purpose, our C5 compute optimized, and our R5 memory optimized instances that there's a huge benefit in running SQL Server on Linux. You can choose the operating system, so you can run that on Ubuntu, Red Hat Linux, or Amazon Linux. So you can, if you're already standardized on Red Hat, for example, or Ubuntu in your organization, you can standardize across one operating system for your SQL Server workloads as well. So tons of customers are modernizing their workloads on AWS. And one key way they're doing that is using containers. And a company called ZocDoc, they broke their monolithic .NET applications. They had a monolithic single .NET application. They broke it down into containerized microservices, and they migrated it to the cloud. And they used ECS, which is the Elastic Container Service from AWS. So if we look at containers in AWS, well, we have two offerings available. We have the Elastic Container Service, which is the original Amazon kind of managed container service. And then we also have EKS, which is our managed Kubernetes service. Now, we know that the experience in running containers is in the cloud. 81% of containers run in the cloud. Of those 81%, 80% container workloads in the cloud run on AWS. So we're super experienced and trusted by customers to run containers in AWS. And not just on ECS, actually 82% of Kubernetes workloads that are in the cloud run on AWS as well. So there's a ton of Kubernetes experience as well. I know it's a very hot topic for a lot of our customers. They're exploring that space right now. And we have support for Windows containers in ECS and EKS, and many customers are running .NET applications there as well. So if you're looking to containerize your applications, if you're looking to move to serverless, or you're looking to run Windows SQL Server on Linux, there's tons of opportunities available there for you as well. So just to wrap up, I finished with the slide that I kind of started with some key metrics there for you on running Microsoft workloads in AWS. We have a ton of infrastructure and reliable, highly available, trusted infrastructure run over years and years of operational excellence with industry-leading performance characteristics and availability characteristics. We have more experience than anyone else of migrating and running Windows workloads in the AWS cloud, and a ton of capabilities from managed services through to support for different operating systems and licensing models in the AWS cloud as well. And of course, all bundled with the security that you need to run your enterprise securely as well. So thank you very much for having me, and I encourage you to attend the rest of the sessions in the summit, and I hope you enjoy the rest of your day.